Okay, good morning. So today we're going to start the introduction to SQL programming. I think maybe some of you have already learned SQL programming, maybe very proficient in SQL programming, but there's some students who may not may learn or may not be very proficient in SQL programming. So I think that's why I'm trying to maybe spend I hope three classes or 2 weeks on the SQL programming. Then we switch to the PR SQL programming, and then I think we pretty much kind of end the programming part. So the SQL programming actually is kind of a called structured query language. So it is supported by all relational database systems. So regardless you're working with Oracle database, you're working with MySQL database, or Microsoft SQL Server, or maybe IBM DB2, and so on. I think SQL is considered as a standard query language for all those systems. So the main purpose of the SQL is trying to retrieve the information from the database that may answer your question or your query about the data stored in database. So in the SQL programming, this list the major commands that we're going to study. So we're going to study standard SQL command, and also we're going to study how we can use compound conditions to pretty much specify multiple conditions on the records in the database, so that we only retrieve the records that satisfy those conditions. And also we're going to study the like operator. It's mainly used to find substring pattern in the string field. Then we use in operator to pretty much to correlate two standard SQL query together. One is kind of defined after the in operator. It's called inner query. The other one is basically the outer query. That's another SQL query. So using the in operator, we are able to kind of correlate the two queries results together. So it's pretty convenient. Then we also study order by, that's used to order the query results. Then we're going to study some aggregate functions, the max, minimum, sum, count, and average. And also we're going to study the group by clause. So group by is a very useful clause that can help us to form the groups based on certain attributes and values of a table. Then we can compute the group statistics using those aggregate functions. And also having clause also has been used with group by clause. So having clause is that when you form the groups, when you get the group statistics, you may not be interested in every group. You're only interested in the groups that satisfy their group statistics that maybe satisfy some criteria, like the average age is greater than like 40, something like that, or average salary is kind of greater than like 60 grand, this kind of stuff. Then we're going to study join tables. So far the discussion, we actually mainly focus on the single table query. By single table query, we mean that we are able to get all the information we need from one table. And sometimes it's not always possible because we may want to retrieve the information that's spread out over multiple tables. Then we have to combine the information of multiple tables together in order to get the information we need. So that's when we need to join tables. So then we also review the subquery. So subquery, I think, is becoming a very, it's kind of more flexible. So means that you can embed an SQL query in any statement in SQL, in the SQL query. So we're going to discuss that. And also we're going to study some aggregate functions based on the joined tables. And we also maybe just list the DDL stands for data definition language commands for creating or modifying table, okay? So we have already said SQL stands for Structured Query Language. So it's a standard language for all commercial relational database systems, and also the open source like Postgres and so on. So it's considered as a comprehensive database language in the sense that it is both data definition language and data manipulation language. Okay, so data definition languages usually start with create, like we create table. Data manipulation language can be select, update, delete, and so on. Okay. Let's see the example here. So this shows a standard select statement. So sometimes we call select statement or select from where block. So a Euro SQL statement contains 3 lines: select statement, then followed by from, then followed by where. Where can be optional. So select statement, we only list the attributes name whose information we want to include it in the final result table. The from clause, we have to specify which table we need in order to get the information. And then where clause used to specify the records in one table or records from different tables need to satisfy certain condition so that they're going to join the final, or they're going to participate in the query and produce the result. Okay, so SQL query, you can tell that it's not intelligent. So basically means that you have to tell the database which attributes information it needs to retrieve, and you also you have to give the database the table list of table names so that database know that which table to go to find the information. So that's why when we specify this select from clause, we have to be very accurate. Okay, and this shows the kind of a we call database schema. So it shows 6 relation schema, and in each relation schema we underline the primary key. So like SSN of employee, for the work sum, we have composite primary key, means ESSN and PNO together work as primary key. We also specify the foreign key. So theoretically, if you know the attribute semantics of each table, if you know what is primary key, and also if you know the foreign keys relationship, then pretty much you're able to write the SQL query correctly. So once again, for the foreign key, it always composed of 2 set of attributes. One set of attributes is the foreign key. The other set of attributes is the referenced key. So that's why we have this directed arc. So for example, if you look at the work sum, the ESSN is the foreign key reference to the primary key of the employee. And the PNO of the work sum is a foreign key reference to the PIN number of the project. Okay. So I know that in the term exam, some of you actually define the foreign key wrong. So basically, either the direction of this arrow is wrong, or even the specification of the foreign key is wrong. Okay, so this is a database schema. So basically, in practice, when you write an SQL query, you actually only need the database schema. Sometimes you may also need the data type of an attribute, but other than that, I think as long as you know the table name, attributes name, key name, the key attributes of the primary key, and the foreign key, then you should be able to write SQL query. So you really do not need to rely on the printout of the database to write your query. The reason is very clear, because here we have very tiny sample database, but in practice, each table may, I don't know, have hundreds of thousands of records, or maybe even millions. So you will be able to print out them. Even you print out them, it's so hard for you to, go over, remember everything. So that's why the database schema is more important. Okay. So, but for discussion purpose, we actually print out this small database. But I just want to be aware that in practice, you do not rely on the printout of the database to write your query. Rather, you're going to rely on the database schema this called database schema to write your query, okay? So let's see the example here. So for this example, we try to retrieve certain columns and the rows of a single table. For example, the question that asked us to list the department name and the manager assistant of our departments. So we know that we're going to get the department info. So the first thing first, we need to know which table do we need. Okay, so if you look at the table, I'm very familiar with the table. We do have a department table. So that table with department name really indicates this table is supposed to store the department information. So from this table, we are able to get the department name, department number, manager's assistant, and the manager start date. Okay. Then if we go back to the query, so let me yes, I'm trying to shrink this window. So I can post the printout. Yeah, I think you're able to do it. Yeah, pretty much. Okay, so it's asking for the department name. So that's D name stands for, and the department manager's assistant, that's the MGR assistant. So basically, it indicates that to answer this question, we only need the department table. And also, we do have the attributes corresponding to the department name and the manager assistant. So that's why we follow the select from clause from statement, okay? So in a select, so we can always start from clause. So that shows that which table do we need. So in this case, we need the department table. So for the Oracle database is table name, attributes name are case insensitive. So basically, so that's why although the printout of the department is all in uppercase, but we can just simply write the department all in lowercase because in the Oracle database that's case insensitive. But if you're working with MySQL database, I'm pretty sure that MySQL database is case sensitive. Okay. So once we know that we need a department, then in the select clause we only list the attributes name. So we know that we're going to get the D name, that's department name. So that's the attributes D name stands for, and manager assistant will be MGR assistant. Okay. So then you can tell that in the select clause we only need to list the attributes name, and then later when we study aggregate functions, then in the select clause we can also list the aggregate function. So, but nothing else. So in the select clause we can either have attributes name or aggregate functions, or both, but we cannot have anything else. Okay. And the from clause only the table name. And here, since we want to put list all the departments info on the D name and MGR system, so that's why we do not have where clause. Okay. So in this case, this shows that this query shows pretty much will list all assistant and manager assistant and department name for each department. So let me log into my Apex account. let me write down my password name so that I won't be able to forget after the class. So basically for the Apex, I think every 3 months it will require you to change your password. So okay, so let's come here. So I think we have company database already created. So if I do the select dname and gr SSN from department, you have to end each SQL query with a semicolon. So if this is the query, yeah. Then if you run it, then you're going to see that it simply just lists dname and gr system for each department. Okay, so this is the query we don't have a where clause. But for example, we have a different query that we don't want to list every department dname and manager's assistant. We may only want to list the research department dname and the mgr assistant dname. Then in this moment we can have where clause. Okay, so for example, if we have a query, a separate query, and where dname equals to research. Okay, so this is a different story. So although it's only list dname and mgr system and also use department table, but compare this one and the bottom one, we do have one actual where clause. So this where clause specifies that for the department records, whichever record satisfy the dname equals to research, then for those records we're going to output the corresponding dname and mgr system. So overall, this query can be translated into retrieve the department name and manager's assistant for the research department. Okay, so that shows when we have the where clause. Okay, any questions? So sometimes if we want to list all columns, then instead of type each individual column and separate by the comma, we can use asterisk in the select clause. So the asterisk basically indicates we're going to output, for example, from department. So asterisk indicate we're going to output every record in the table. So pretty much simply display a table. Okay. So let's see the this result looks like. So copy paste. Then we do the run. Then it's pretty much print out list all attributes in the order that attributes is defined in the table, and then all records. Okay, so asterisk, you can use asterisk only if you want to output all columns of a table or several tables that in the from clause. Okay, so next one. So in the where clause, so the where clause will actually specify kind of conditions on attributes. So usually the where clause is in the form of the attributes name, then comparison operator, then the constant value. Like we just see that, like the dname attributes name equals to single quote research. So for the char string value, we have to use single quote to enclose it. But for the integers, that's no need. So you just simply type the integer without using single quote. Okay, so let me probably. So the second form of the comparison in a where clause is attributes name, comparison operator attributes name. I think usually you probably mostly often see the attributes name equals to another attributes name in the table drawing condition. Okay, so here give you some example like F name equals to John, last name equals to Smith. So if we have these two conditions, we can use the compound operator to combine two conditions. So we can either use and or. So I hope you understand the differences between and or. For example, here we have two conditions. If we connect these two conditions using and, that means that both have to be true in order for this compound condition to be true. Okay. If we use or, like the second example, salary less than 30,000 or sex equals to F, that basically means that as long as one of these conditions is true, then it is true. So for this compound condition, as long as one is true, then the whole compound condition is true. So now we have the query that retrieve the birth date and address of the employees whose name is John Smith. So it's talking, we try to retrieve the information about the employee. So usually we have to go to the employee table because that's the source table that contains information about the employee. So it's asking the birth date. We do have B date in the employee table. Address, we also have an address column. So it means that these two attributes can be found in the employee table. Then we are not trying to get everyone's birth date and address. Rather, we want to get the birthday and address of the employee whose name is John B. Smith. So that indicates when we record the employee's information in the employee table, we actually split the first name, last name, middle initial into separate columns. So that's why it means that John corresponding to the first name, B corresponding to the middle initial, and L and the Smith corresponding to the L name. Last name. So then I think with that we're able to write the query. So we know that for this query we have to use the employee table. Okay, so use employee table. And the from clause, basically the from is the one that the table we need. So that's the employee. And then the select clause, that's the attributes that we need to, whose information we need in the resulting table. So that will be the birth date, the B date corresponding to the birth date, and address attributes. So these are the two attributes we want to include in the final result. And then we do have where clause because we need to specify which employee's birth and address will be retrieved. In this case, it's the John B. Smith, so that means that we have to return the first name equals to John and middle initial equals to B and L name equals to Smith. Okay, so this and is very important. So that means that unless all three conditions are true, then we're going to output the corresponding B date and address of that tuple. So we use and. So if we have like John Doe, then John Doe will not be satisfied this condition. Okay, well, we have to make sure that first name, last name, and the middle initial they all satisfy the specified condition. Then we're going to output the corresponding B date and address. Okay, so in this example, we only have one John B. Smith. If it is possible, maybe we do have employee have the same middle last name and middle and then first middle and last name. Then in that case, this table will produce two sets of birth date address, one for each John Smith. Okay. So let's see. So this shows the comparison operator that can be used in the where clause. So we can have equal to, greater than, less than equal to, greater than equal to. Then the last one is not equal to. So that's kind of less than the greater than. So the two operate together form the greater than equal to. Okay, so this one is kind of different from most of the programming language. So I think in Java and the C++, I think that's the different operator for the not equal to. Okay, and also the char string values in SQL are case sensitive. So in this case means if you specify the last name as capital Grove or the small Grove, then you totally have different result. So let's probably review what we see before. Okay. So in this example, let's first run this query. So that means you may need to review the original table, preview the original table, the data stored in the original table to see how the data is stored. Okay. The reason because when we record the first name, last name, implies name. Okay, so those names, depending on the application, sometimes the name can be used all uppercase, sometimes maybe all lowercase, sometimes maybe capitalized, sometimes maybe no format. So no format will be very, very bad. Okay, so that's why you have to go to the to see the original record to see what kind of patterns for the person's name. Okay, so if we run this, delete is not my tab. Okay, this actually shows John Smith, the birth date and address. However, for example, when we run this query, instead of have capitalized John Smith, we have small John. If we try to run this query, then we will have no data found because the char string is case sensitive. So if we put small John, then database will be looking for the first name that matches small John, not capitalized John. So apparently, in this table, we don't have anyone whose first name is small John. So that's why we have no data found. So in this example, I just want to show you that the char string is case sensitive. So when you write SQL query, when you need to compare the char string value, you have to make sure that you have the right case. Okay. Another example is that, for example, the department name is like capitalized, right? So if we, for example, if I'm trying to get at the name, MGR SSN from department. So if we get like D name equals to like research. Okay, so if you check the table, department table, you compare that the department name are all in the capitalized. So basically, it's not all uppercase. So if you try to use uppercase, then you will have no result. But if you change to the capitalized research, then you will have then you will have the information. So then you may ask, then how can we handle if the data recorded in a database are in a mixed format? Some are all in uppercase, some are all in lowercase, some may be the capitalized. So how can we handle this situation? I think maybe the root cause to handle this situation is that you go to the base table to do the data normalization. So it means that you make the rules that for all the char strings either capitalized or all in small case or all in uppercase. So in this case, it will reduce the chance that the query will miss some records in the result. Another possibility is that you're going to use some functions, for example, like I do the upper this function, so it means convert attributes value into all uppercase. Then we do so we kind of compare with uppercase words. Okay, so I use upper this built-in system function. So dname attributes. So this upper dname means that it will convert dname values to the all uppercase letters. Then we can compare. Okay, so if you run this one, I think you have information. Okay, because it's first converts the result into all uppercase, then convert to the all uppercase. Or you can do the lower, another. So then you have to use all lowercase. So this is maybe the way that you can handle if the data is not normalized, then you can handle different situations. Then you have research. Okay? So that's this one kind of thing I try to basically I think the best way, instead of using upper lower, I think best way you standardize the base table before put into production, so people knows what's the format of the char string values. Okay. Okay, so let's move on to the next one. Okay. So for every employee who works more than 20 hours on a single project, list his her SSN and the project number. Okay, so in the query, we kind of specify the conditions on the project working hours, single project working hours, and then the request that we have to list the employee's SSN and the project number. So we need the SSN info, project info for the output, and also we need the hours info, project hours for the conditions. So then, given this query, I think there's one table called worksum table. Okay, so this worksum table contains ESSN, that's the employee SSN, PNO stands for project number, and hours. So pretty much means that we may only need this table to answer the question we have here. Okay, so select. So I think from class we can put usually we can put the from class in the beginning. From class we have to specify the condition first. Okay. So that shows the worksum table we need. Okay, then we can list the select clause. So select clause will be the ESSN from the worksum table, and the product numbers will be P and O. Okay, then from worksum. But we do have a condition that we are interested in the employee who works on a project, a single project, more than 20 hours. So that means that we have to have the conditions in the where clause specified on the hours, so hours greater than 20. Okay, so this is how we write this query. So we identify the table we need, identify the attributes we need to output. So we list those attributes in the select clause, the table name in the from clause, and then we also need to identify if there's any conditions we need to specify on each record in that table. So in this example, we do have condition hours greater than 20. Okay, questions? So this is how the result looks like. So using compound conditions to combine multiple conditions in a where clause. Okay, so we can have and, or, not. And basically, we can use and to connect multiple conditions. Then that if we use and, that means all conditions must be true in order to be true, the compound condition to be true. If we use or, that means either or. Okay, so if you use or connecting two conditions, that means as long as one condition is true, then the whole compound condition is true. If we use or connecting multiple conditions, that's pretty much can be equivalent to given, for example, 5 conditions. As long as one is true, then the whole compound condition is true. But you should be careful if you mix use and or to combine conditions. So it means that you also use both and or to try to connect conditions together. Then the order of the condition will matter. So usually, you probably, I think, for the best logical to radio codes much easier, you probably can use parentheses to enclose the condition. So you know that condition within the parentheses will be evaluated as a unit, and then you're probably able to have the order how to evaluate the conditions and how to combine them together. Okay, then the not condition basically means the negation. So if the condition is true, then if you put not before the condition, then the whole compound condition becomes negative. If the condition is negative, after you add not, that it becomes true. Okay, positive. So let's see the example using operator not. So list the name and location of projects that are not controlled by Department 5. So it's asking for the name and the location of the project. So I think we probably need to first investigate if the project has all the information we need. So it has project name and project location. And also controlled by Department 5. So we also need to examine the controlling department number. So I think D9 standing for the controlling department. So that's pretty much, I think, the project table is enough for us to get the information we want. So we have select from okay. So it's asking the name and the location. So we just simply find out the attributes that stands for the project name and location. So that's going to be P name and P location. Okay, once again, the attributes name are case insensitive. So that's basically whether you capitalize or not is not a big deal. Then the table name with the project. Okay. Then the where clause, because not controlled by Department 5. So we can use not condition. That means we first make condition D number equals to 5. Okay. So this is a condition. Then we apply the not in front of it. Okay. So that's basically if the D number equals to 5, then this compound condition will be negative. So then the P location, P name will not be output. Then only when the D number not equal to 5, then this condition will be negative. Then add the not, then this becomes true positive, means true. Then we're going to kind of output the corresponding P name and P location. I'm sorry, I think my allergy is getting worse, so it's so hard to make me kind of whole mess up. So, okay, so let's use the not. Sometimes we can also use not equal to. Recall that in the SQL query, we have not equal to comparison operator at the location from project where D9 not equal to 5. So this is another way to write the query, okay? So usually, I think this not is a little bit complicated. So we always have to do the negation of the condition. And this D number not equal to 5, I think is much easier for us to understand and also read the code. So it means that as long as D number is not equal to 5, this query will produce the corresponding D, P name, project name, and project location. Okay. questions? So alias. So alias basically is a way that we can rename the attributes in the resulting table. Okay. So sometimes we have a need, for example, the attributes name, when we list attributes name in the select clause, the name might not be that easy to understand. Then you can give a different name in the resulting table so that that column, the semantics of that column is much easier to understand by the user. So when they read the column, they know exactly what does that column mean, okay? So if you want to do the renaming, so in this case, renaming happens in the select clause. So you have attributes name, then a space, then the rename, the new name you want to give. I think for the MySQL, you have to use as in between, okay? But in the Oracle, I think you do not need to use as, but we can try, okay? So Oracle usually, you just separate the attributes name with the new name by the blank space. That's it. Okay. So let's test it to see. Because I think the MySQL is kind of after it is bought by Oracle, I think they trying to maybe share some kind of notation as text. So if we run this one, invite statement, how come? Let's try it again. I think there's nothing wrong. Huh. I don't think you need to have as. Sometimes if you know the code is correct, then if it's not running, I think most likely the network connection problem. So you see that we don't have anything else. Select mgr SSN. It's called mgr SSN from department. So we don't have any title here, and we don't have anything. So let me delete. So if it's not working, that's pretty much mean the service. So weird. Okay, let me do from SSN. So in this case, I think maybe the service is not responding. So whatever you gave the query, it won't give you a result. You see? So invalid SQL query. I don't see any arrows here. Don't see any, I think the command. So maybe let's run the code we ran before. Yeah, we can have history. So we know some so I think, okay. Okay, let's run it. Okay, now it's working. Then we don't have where clause. Okay, I think now it's responding. So now we just do the manager SSN. Now it's working. So I think sometimes system is not reliable. So in a stable status. So you just be patient. So now you see that in the resulting table, instead of have mgr underscore SSN, it has manager SSN. So that's basically kind of rename the column header in this resulting table, okay? However, this renaming only happens in the resulting table. So every query produces a result. The result can be represented or can be viewed at a table. So then the alias only applies to the resulting table. So if you go to the department table, then I think that's it. Then the department table still have original column name. You see the M judges, okay? So here I just want to let you know that alias only applies to the current query result. So that's kind of scope. It will not affect the base table or the naming of attributes of other tables. Okay, so that's you have to be aware of that. So next one we study the like operator. So like operator is used to retrieve data where there may not be the exact match, but we can looking for the substring pattern matching in the char string. So like is operator for the sub-pattern match, and then we also have two operators to combine use with defining the sub-pattern. So the percentage replace an arbitrary number of characters. So it can be characters, can be numbers, can be anything. And the underscore just used to replace a single character. So here give you some example of using the percentage like that single quote percentage, capital centra, then percentage. So that means that as long as centra appears in a string, so in that string it may have any number of letters before the centra and any number of letters after centra, that's fine, but as long as centra appears in the char string value, then this condition is true. Okay, so that's why we can have like for this string, char string, then it match the percentage centra percentage. And the centralia also satisfied because this percentage means any number, it can be 0. Okay, so then if we use underscore, then we have much stricter conditions. So each underscore only replace a single character. So for example, if we define the substring pattern like T underscore M, that means that we're only looking for the 3-letter string, and the first letter is capital T, the last one is capital M. Only the middle can be anything. So it can be Tom, Tim, and T3M, and so on. Okay. So let's see the example here. Retrieve all employees whose address is in Houston, Texas. So here it's only asking all employees. So basically, usually when it's asking for the person, if we have person's name, we are going to output that person's name. Okay. So in this example, we do need the employee table because it's asking for the employee info, and also has the address condition that address is in Houston. So if we review the address column, we can tell that address is represented in the standard US address format. So it starts with street number, street name, and the comma, and then the city name, and the comma, then the 2-letter state code. That's kind of usually. So then in order to see which employees live in the Houston, then we can use substring pattern match. So where address like, so that's the operator to looking for the substring pattern. Then I think we're only interested in the city name, so we use this percentage to represent any street name, street number, and then the Houston. Now we do another percentage. Okay, so that's it. So then in the select clause, it's asking for the employee. So I think you can either retrieve everything or just retrieve the employee name info. So that's another thing you can do it. Okay. So here we use like operator to specify that the condition we're looking for the substring pattern match in the address. as long as address contains capital H Houston, then it is fine. Okay. So if we run this query, okay, so single quote, we need to replace the single quote. Okay, then we run it. So we have 3. We probably can verify John Smith. Oh, not 3, I'm sorry. But are they all in Houston? No. 1, 2, 3, 4, 5, 6. That's 5. Am I counting wrong? Yeah, it's 5. So it shows 5 records returned. So that I think that should be wrong. It should be right. Okay, let's move on. Another one, find all employees who were born during the 1950s. So it's still about employees, and we know the employees table does have the birth date. Okay, so I'm not sure if the birth date in the table we have here had the same format. So let's first try to query the B date. Okay, you see, this B date is in the month/day and the year. So it's different from what we're seeing here. So it means that if we specify the years, the 1950s, we need to focus on the last 4 digits of the, or last 4 symbol of the address. So I think in this case, we use the similar query. Sorry. Select. So we need the employee table. And then the where clause, we're going to compare the B date. So B date like, okay. So we know that for the data we have in a database, the format, the date format is different from the table we have been showing here. So the last 4 digits representing the year. So that's why we're going to have percentage, and then the last 4 digits should be 19F. Then the last one, as long from 1950 to 1959. So the last digit can be anything. So that's why we use this underscore to representing there's 1 after the 5, and that's it. Okay. So now we just simply do the name, the initial, and then last name. Okay, let's run this code. Sorry, to see what we have here. To see it's correct. So once again, the single quote is not right. Sorry. Now I know why we have a kind of ruler here. I think just used to trigger the light. So light is always off. So used to turn light. Okay, so let's run this one to see. Okay, we only have let's see the date. We only have Franklin 1 born in 1950s. Okay, is that right? Let's see. Okay, so yeah, we only have 1 in 1950s, but we have multiple in the 1960s. So if we change this 195 underscore to the 196. Let's see what we have here. Now we have multiple. You see the Bush data, right? Okay, so that's called a substring pattern match. Okay, so order by is very it's also very useful. So especially nowadays, we always working with a big database. Each table may have, if not have hundreds of thousands or millions. So I think one time I'm working with a database with one table has about 200 columns and about, if I remember correctly, about 11 million records. So in this case, if you just run your query, then you may generate more than 1,000 results, maybe if you're lucky. If you're not lucky, maybe hundreds of thousands. So it's so hard for you to go over the resulting records to find the information you're interested in. So that's why using the order by, you basically order the tuples in the resulting table by a single attribute value or by a combined attribute values. So, and here shows you one example. So we select start from department, order by D number. Okay, so by default, the order by will produce a kind of a records in the ascending order of the order key. So D number is called order key. Okay. So if you want to use descending order, then you have to order by D number, then to the DSC. That's basically in the descending order. So let's run this one. Okay. So copy. So you see the D number is ordered by the descending. So this DSC is indicate descending. If you do not specify the DSC after the order key, then default it will be not either internet is very slow or the server is very slow. Nothing wrong. Okay. Another thing that, for example, you know, the workshop we do have hours. Then we can order by hours. Then in the, for example, descending order. Okay. You see, I didn't change anything. So then this time it's running. So if you're looking for the hours, let me make it smaller. Make an hours and the order is descending order. Okay, so sometimes you may want to order the query results by several different attribute values. I think this may be the good example for you to, I think, able to view it. So maybe we first order by the P number, okay? So means that we order the results by the P number. So results from the workshop tuple with for the same P number will be output, will be grouped together. Then we order by hours, okay? So what does that mean? Means that the records with the same PNO will be grouped together, will be kind of showed together. Then for those records, we're going to order them by the hours in descending order. So let's see what we have here. Come on. I think today's the server is really slow. Okay, finally. So now we compare that by default, because we didn't specify any DSC, so that means by default, it will order the records, works on record by the P number in the ascending order. So that's why the first records with P number is 1, then we have 2, then we have 3, and then 10. Okay, I think we have more. So let's you see that, then 20 and 30. Then for the group, the records with the same PNO, then they will be ordered, records will be ordered by the hours in the descending order. So this is very, I think it's a very convenient way for you to first order the query results, then you can quickly pinpoint the tuples that you're interested in. So that's why it's very useful in the reality. But you have to be aware that the order by and the group by are two different, totally different command. So order by basically will be the last step of your query execution. So it will first produce the results, then order the results tuples by certain criteria. Group by basically is a valid SQL clause. It's involved in the query result generation. So it will group the resulting records by certain group by attributes, and then usually you're going to calculate some group statistics, like the number of the tuples in each group, or the maximum values for certain columns in each group, and so on. Okay, so yeah, I think we have one more thing, then we can stop. So the in operator. So in operators compare a single attribute value with a list of attributes values, or compare a record with a list of records which will be viewed as a table. So it's just kind of examine the membership. So compare a single value with a list. If we use in, we simply check if that single value appears in a list of the values. If we compare a record with a collection of records or a table, we simply examine if that record appears in that table or not. Okay, and most of the time, when we're using this in operator, we can use a separate SQL query to generate a list of values. So in this case, it makes this our way of writing query more flexible and powerful. And let's first read this query to see what it gets. So we have select F name, L name from employee, where SSN in, then parentheses, select SSN from dependent. Okay, so basically for this type of query, this specific one, the database will first run this query. It's called the inner query because it's embedded in another SQL query. So this query is called outer query. So the inner query will be executed first. So the inner query will produce a list of ESSNs from the dependent. So that list of ESSNs actually stands for a list of the employee SSN, or a list of SSNs of employees who have at least one dependent. Okay. Then the out query will use this list. So the out query will be executed in this kind of in this way. So database will go to the employee table. It will retrieve one record, employee record at a time. So starting from the first record, okay? So then it will compare the record SSN with this list. If the SSN appears in the list, that indicates that employee has a dependent, then we output the corresponding first name and the last name of that employee. Okay, so in this case, it's very convenient, means that we can use a standard SQL query to generate a result. and the result will be used by another SQL query to get the final result. So this is called the in operator, and this is called the inner query and outer query. But I think when we start to move on to the subquery, that's very sophisticated way of writing SQL query by embedding, SQL query in the select clause, for example, from clause, or even the where clause. So this one is the where clause. So we're going to revisit this one again. So, but I want you to understand how the in operators work. So it's compare a single value with a list of values. So if the single value appears in a list, then it returns true. If the single value does not appear in the list, then it returns false. So that's why this query will produce the name of employees who have a dependent, at least one dependent. So for the employees who do not have dependent, so this where clause will return false because it will compare the employees SSN with a list of employees who have dependent. Apparently that will not be true. Then the corresponding employee name will not be output. Okay. Okay, so I think I want to stop here. So I think next class we probably can study the aggregate functions. Then we're going to study the drawing tables. Means that we're going to combine multiple tables together to find information we need. So any questions? So I think I'm going to post another a third SQL actually assignment, the first SQL assignment on Blackboard. Okay. So if you don't have any questions, then we stop for today. Thank you.